Hi, everyone. In this video, we want to look at the conversions between moles and volume under STP. So STP stands for standard temperature and pressure. And this pathway that we're going to go to between moles and volume is only for gases under STP conditions. So if the temperature is certain temperature and the pressure is certain temperature, and the pressure is certain pressure. So this is the general chart we have for going from moles to grams or moles to molecules and atoms. And then we have from moles to liters. So for now, for this video, our focus is just between moles and the liters. So I've already have other videos showing the conversion between moles to grams or moles to molecules and atoms. So if you want, you can look at those after. But for now, the focus is just between moles and liters. And this only, again, applies for gases under STP conditions. So let's talk about STP, to see what is the standard temperature and pressure considered as. So there is some textbooks, they consider standard temperature to be 0 degrees, like all of them basically say it's 0 degrees Celsius, which is 273.15 Kelvin. But the standard pressure might be different depending on the textbook or the course you're taking. So for standard pressure, the pressure is 1 atmosphere in some cases, which is 101.3 kilopascal. But then there is some textbooks that they define standard pressure as different. This time they say the pressure standard is 100 kilopascal instead of 101.3. So it's just only 0.987 atmosphere. So it's a little bit less than 1 atmosphere. For example, IB chemistry, it defines standard pressure as 100 kilopascal, not 101.3 kilopascal. So depending on which scenario your school is going with, you can the condition is going to be different. So if it's the top one, if the standard temperature is 0 Celsius and the standard pressure is 1 atmosphere or 101.3 kilopascal, then 1 mole of gas will occupy a volume of 22.4 liters, or we can say the molar volume is 22.4 liters per mole, meaning any gas, doesn't matter if it's CO2, nitrogen monoxide, nitrogen dioxide, all of them, if there's 1 mole of them, they will take up 22.4 liters. So imagine putting 1 mole of a gas inside a balloon, and the volume it will take up is about 22.4 kilos if the temperature is this and the pressure is this. But then for the second case, 1 mole of a gas will occupy 22.7 liters. So the number is 22.7 liters per mole. So we say that's the molar volume of this gas. So make sure and check which ones your school uses. But normally, I mean, for my conversions, I'm going to be using 22.4 liters per mole for STP. But again, all the questions that I'm going to do right now, if your school is using the other number, you can simply substitute 22.4 or by 22.7 and then use it for your calculations. Okay, so this is now what we're looking at. So we say 1 mole of a gas at STP condition will take up 22.4 liters. So that's our scenario right now. So let's look at 2 examples here. So first is asking us to find the volume of 3.51 moles of CO2 gas under STP. So we know the moles and we want to go to liters. So it's simply one simple step. We start with the moles. Next step is to cancel the moles. So mole has to go at the bottom, liters has to go at the top. And then we know based on this chart that always for every 1 mole of gas, the volume occupied is 22.4 under STP condition. And again, this only applies for gases, and this applies to the standard temperature of 0 degrees Celsius and standard pressure of 1 atmosphere or 101.3 kilopascal. So this way moles can cancel with each other. And then our final answer will be the liters of CO2. So we end up getting 78.6 liters of CO2 gas under STP condition. Now let's take a look at another example. This time we're working backwards. So this time they're asking us for the number of moles of NO or nitrogen monoxide under STP. They've given us the liters, the volume, sorry, in milliliters this time. So we know the conversion between moles and liters, not moles and milliliters. So first step for us is to convert milliliters to liters. So to do so, milliliters has to be at the bottom, liters has to be at the top. And we know for every 1 liter, there's 1,000 milliliters. 1 liter is larger than milliliters. So there's for every 1 of it, there's 1,000 milliliters. So this way milliliters can cancel out. So far we got the answer in liters if you plug it in the calculator. But then next conversion is to convert liters to moles. So liters this time has to be at the bottom to cancel out. And then we want to get the number of moles. So it has to be at the top. So we know the conversion between them is, again, for every 1 mole, there's 22.4 liters. So this way the liters can cancel out and we can get the final answer in moles. And this way we find 0.00203 moles of nitrogen monoxide on their STP condition. Okay, I hope you found this video useful. If you like it, make sure to subscribe for more videos. I'll be posting more, and I'm going to tag the other videos that I mentioned in here so you can see the other conversions going from moles to grams or moles to molecules and atoms. All right, have a good one.